Hello, welcome back to LeetCode Daily Live, where I do LeetCode Daily questions raw and cut. So let's get started. So today we have a medium. Oh, actually, I should mention yesterday I forgot to record, so that's why there are no videos, if you're wondering. So, let's get started on today's one. So today's question is construct the I never know how to pronounce this, but it's basically like the largest in characters. Largest valid sequence. So given an integer n, we want to find a sequence that satisfies all the following. So integer 1 occurs once, each integer between 2 and n occurs twice, and for every integer I between 2 and n, the distance between the two occurrences of I is exactly I. So the difference between two numbers on the sequence, AI, AJ, it's the absolute difference of their indices, right? So I'm guessing like from reading this, so we have two twos, and the two twos have to be exactly two indices apart. So it can be like on the second index, and then it can be on the fourth index, or like it can be like 8 and 10. Like basically, like they just have to be two apart. So we want to return the lexicographically largest sequence. So it is guaranteed that under the given constraints, there's always a solution, right? So what are our bounds? Well, it's a very small bounds. So we are thinking of like some exponential algorithm, maybe. Um, yeah. So let's see. Oh yeah, this is just explaining the sequence. So let's see for here. So we have so for 3, the threes are 3 indices apart. The two are 2 indices apart. So that makes sense. Um so like because the bounds are so small, I'm actually thinking we can just brute force it. So because we want the lexicographically largest one. Sorry for the bad pronouncing, perhaps. But yeah, basically what that means is we want to try the larger numbers first, right? So let's say for n equals 3, what do we want to do? We want to try putting 3 at the beginning first. So we can put 3 there, and like because n is equal to 3, we know we have 5 spots, right? So if we put 3 here, we are basically forcing the other 3, to be right here, like 3 apart. And then we can try 2. So when we put 2 there, we notice that we can't put 2 because like this is taken already. So we want to take that back, and we want to try putting 1. And then we can try 2 again, and right now it works. And we can guarantee that if we do it this way, because like we are doing from biggest to smallest, we guarantee that the first one we found correct is going to be is going to be the largest solution. So actually let's try 4 as well, maybe. Yeah. So if we have 4, so we will have 7. Like the output will be of length 7. So let's try 4 first. So that means we have to put 4 here. And then what do we want to try? We want to try 3, right? But we can't put it here anymore. So pardon me. Yeah, so we want to do 2 here, and 2 does work. So we have we have the next empty one. So for this one, we want to put 3 there. And this time it does work because 3 apart is available, and then we just put 1 at the end. So what is the time complexity for this? Let's think about it. We have like the maximum is 20, and every time for every for every number, we have to try for let me think about this actually. Like the time complexity is not the easiest to evaluate for this one. Uh, well, but the worst case, like we have to try 4 here, and then 4 doesn't work, we have to try 3. Like for this here, if 4 doesn't work, potentially we have to try 3, and then we have to try 2, and then we have to try 1. So we actually have quite a lot of sequences that we have to try out. But the thing is, when we are trying like when we are trying the numbers at the front, we don't actually care about, like we don't have to try the other 4, like on all the other positions. So um yeah, so I think the time complexity for this, would it be factorial or 2 to the power of n? Yeah, we definitely have to think about it, because, well, if it is factorial, it will be way too slow. And yeah, I'm pretty sure like 15 15 factorial is like yeah, it's like 10 to the power of 12. So like we definitely couldn't do that. Yeah, but yeah, I'm gonna think a bit harder on the time complexity for this. Yeah, so for the first number, well, we have to try 4, and then for the next one we can try 3. So that means like we have to try 4, 3, 2, 1. So that's like 4 things to try out. And then the next one, well, we will have like for the next number, potentially we have like we have another 3 numbers to try out. So like we have to try 3, 2, 1, and then here we have to try 2, 1, and the last one will be 1. So yeah, actually this could be factorial, which for 20 honestly it could be too slow. But it definitely works. Just worry about the time complexity here. Well, but I guess there's another thing, is that because we are looking for the largest, we are not actually looking for all of them. I think you find the solution pretty early on. So yeah, and like let's say for 3, right? Like after we get a number here, uh well, we don't actually have to try like all of these stuff afterwards for 3, because, well, we know that we can't fit there anymore. So I think a lot of it actually gets cut out, and like because we are looking for the largest one, I think it should be fine. But yeah, let's code it up first, and then we will see about it. I'm pretty sure it should work, but maybe it doesn't. We can see. So yeah, let's get coding. So if n is, well, we're given n only, so we want our array. So does it call it anything? Just largest valid sequence. So let's set all the unset ones to -1. Maybe we can use a constant here. So empty, maybe -1. So empty for, well, nothing in range. Well, we want n times 2. So we want like all the number appears twice except 1. So we have to do a -1 here. And if it is 1, yeah, it will only be 1 element in there. So, and then we probably want a way to store like to store what numbers have we not seen yet, and if that if that scene array is empty, well then we can just return the answer, right? And we are guaranteed that there is an answer. Yeah. So well, there are many ways to do it. Maybe we can just loop through it, or we can do like priority queue. Yeah, actually, how does priority queue sound? Well, it will do the job, but well, in Python, like PQ is a mean. It's a min heap. So, but we want a max heap. So it's not that convenient either. Yeah, maybe we'll just use an array then. Yeah. Um. Or maybe even like a scene array would work. But yeah, why don't we just use an array? I think like that would be the easiest maybe. So we want scene. Yeah, let's make scene, and then so we want 1 to n. So we can just do so false for I in range. Let's do n plus 1 because we want 1 to n, so it is 1 indexed. So we can do that to be slightly more convenient, I guess. So let's do that, and then let's go down here. Yeah, honestly, like maybe sorted list works as well, but like my point is that, well, yes, using a scene array would be on, but but then like if you use something like sorted list, well, it is technically log n, but it has a lot of overhead there, so it might not even be faster. So maybe using a plain array is even faster, and we just check like what numbers like we have seen yet. So, oh, actually, I have a better idea maybe. So we use a set, and then we just see like we just loop from the largest number, and then we see which ones we have seen yet. So we can just do well, let's set it as while true first. We might have to change this later, but let's just set up the loop first. So well, what do we want? We want to find the first position that's not empty, and then we want to put the largest number that is not seen yet in there, and then we want to put it like at the back as well. But if that place is not empty, we want to try the next number, right? Yeah. So yeah, what if we use a function instead? Like maybe that'll work as well, like using a function. And like we just do recursion. Yeah, like this is like some backtracking stuff, which is probably not that easy to code up. But yeah, let's get to the drawing board and we can think about it. So, well, so for the first one, we want to try well, we want to try the biggest number first. But like how do we know like we want to get to the next one, right? I guess one way to do it is like we have a like we have an index that keeps track of the current like the current empty one. So like after we put 4, like we go to the next one, and then if nothing works out here, like if 3, 2, 1, if all of them doesn't work, like we just have to well go back, and then we try like the next number basically. Yeah, honestly, let me try to remember like how I did the Sudoku one. Like with backtracking. So every time we add a number in, maybe I did use a function actually. Yeah, maybe like something like yeah, I think we need to use a function actually. And then we just, yeah, let's see if this works using a function. So we have backtrack, do backtrack. So what do we have to input? I think we have to input like where we are at. So that will be the index. And then, so what do we actually want to do here? Well, we want to add the largest number in. Right. So for for I in range, we want to check from, well, the largest number all the way to 1, so exclusive, it will be 0, and then we are doing it backwards. So we want to try, let us think about the different scenarios, right? Yeah, this question is definitely not an easy medium because it has backtracking, but so for I in range and 0 minus 1, so if I in scene, we want to continue, so that means like we have seen that number already, like in somewhere else, so we don't want to touch that number anymore. And then we can try right, wait, actually, yeah, we have found the number, like we have found the largest unseen number from here. We want to first check if it works first, I think. So yeah, actually, if it is successful, we should return a boolean. So if we have tried all the numbers and, well, none of them works, we have to return false, I think. But otherwise, oh yeah, actually, let's go here first. So we have seen a number. We want to check, so if largest valid sequence, so that's the current store we have, and we want the current index plus I, so that would be where, like let's say we choose 3, we want to check whether like the place that we want to place the first 3 in, we want to check whether like the index, like 3 after, like whether it is empty or not. So if it is not equal to empty, we also want to continue. Otherwise we are able to actually put that number in. So we want to do largest valid sequence index would be equal to I, and like the I spaces afterwards will also be equal to I. And we want to do scene.add, so we want to actually add I in, and we want to see whether it works for the rest. So we can do something like so if do backtrack, so if it is successful, well, we still have to find like where the index should be actually. So if do backtrack, yeah, actually, let's do this here first. So we want to return true, like we have found the answer, we are returning the answer now. But then we actually also want to check next index. So we want to find where that should be. So while next index is smaller than the length of largest valid sequence, so it hasn't reached the end yet, and we also want to check if largest valid sequence, like if for that index, is it empty or not, right? So like we want to go to the next empty slot, not like a spot that is filled in already. So we can do this and well, actually not equal to empty. Well, we want to check the next spots, and well, if next index is all filled in, then we don't have to do anything. We can just return true at that point. Yeah, but do we want to check it like this, or do we want to check it up here? I think it should be the same, honestly. Yeah, we can just do here. So if next index, if it is equal to the length of largest valid sequence, that means the whole thing is filled in, right? And we can just return true on this point. Or if we go to the next index, the next empty index, do we need anything else? I think this is all we need. So if it is if it returns true, that means like we have a valid sequence now. We can return the answer. Well, otherwise, what does that mean? It means that this number does not work, right? So we want to set it back to empty, and we want to remove. I think remove is the harsher one. So like it would. Is it discard or remove? I'm pretty sure it is remove. So remove like if I doesn't exist in scene, it is going to raise an error. So it's just like maybe a bit safer for us. So we want to set these back to empty as well. So empty, empty, and then we'll try the next number. If the next number also doesn't work, well, we are just going to return false at the end. So we know that that wouldn't work. So we know so we know that like putting like the previous number on that slot would lead to no solutions. So like the previous like do backtrack thing can do its own thing and then try the next number and stuff. So what we want to do now, we want to run do backtrack. So do backtrack, and we want to start at 0. We want to start at 0th index, of course, and at the end. So after this has returned everything, we can just return largest valid sequence at the end. Sequence. I hope. Yeah, I'm not confident that I got this right, but let's see. Well, it could be correct. Runtime error. Yeah, that's not good. So what is the issue? Right. So it is possible. Wait, but for 3, it shouldn't have any issues actually. I think for 1. Actually, I'm just gonna print this, see where we got wrong. So I'm gonna print index plus I, and then maybe we can print I as well to just know like where we've gotten up to. So the last thing it got is actually 2.6. So for 3, well, 3 makes sense that it looks at 3. For 2, well that will be like going in here, looks at 3, finds out that it doesn't work, and then it tries 1. Yeah, actually we have to deal with this as well. So actually if I is equal to 1, that's an edge case, right? Because 1, we only have 1 once, so we're just going to set that number to 1, scene.add that, and then maybe we can do this, maybe. So else, so if it is 1, we only want to do that for both of them. We want to add it in, and then we want to look at the next one for all of them. Yeah, we want to find the next spot that is not used. And yeah, I think like everything else is the same. We just have to do here. So if I is equal to 1, well, largest valid sequence index, I'm going to set it back to empty. Else, just do that, and scene.remove. What about now? Yeah, okay. Yeah, I just forgot about like the one, like the I equals 1 edge case. So did I print anything extra? No, I think I removed the print statement. Yeah, let's see. I'm just worried that it might be too slow. It doesn't look like it. It seems like I am still running into edge cases. So let's do use test case. So n is equal to 2. So what is the answer for n equals to 2? It should be just this, right? Yeah, so actually let's print out I and index again, see what happens for 2 and why is it being buggy. Right, so we have 2 here, but then somehow the index is 1. So for 2, 0, it really should have checked that, right? Yeah, I'm a bit confused on why 1 didn't work here actually. So yeah, so it should finish here in 1, 1, but somehow it did not. Oh, I think like for the check maybe. Where am I checking the this thing here? So we should do if I is not equal to 1 and that. Well, because we are guaranteed that like when we are only putting it in one spot, right? So we can guarantee that that spot is empty already. So yeah, another edge case for 1. Let's see if we spot anything else. I think everything else is the same. I totally could be wrong though. It's still out of range for 5 this time actually. So if I is not equal to 1 and the largest valid sequence, wait, but if I, that's very strange. If I don't have this, 5 returns the correct answer, right? Yeah, this is very confusing, not gonna lie. Yeah, maybe let's print out the thing again. So if I is not equal to 1 and we only want to check that if I is not 1. Okay, so we got to 2 and 7. That's just very strange. But 7 is the length of oh, for 5 it is not maybe. Alright, so I is 2. The index is 7, so it is putting it all the way at the end now. Right, we definitely also need a check that basically stops you from adding if this is too large. So Maybe that's what we have to do. So, and like we need another end case. Index I uh is greater or equal, well, to the length of largest valid sequence. I think that should patch it. Still out of range. That is very strange. So it has 4 and 5 now. But if it is 4 and 5, there should be 9. The largest valid sequence. Oh, because we are doing OR. Right, so we should actually set this to OR. And then we can do it here. Okay. Again, I'm not too confident that it works, but let's give it a try. I'm just worried that it could be too slow. Okay, it doesn't seem like it is too slow. So my hypothesis is correct. It actually gets cut off really quickly. Yeah, let's look at the editorial and see like what the so they suggested backtracking as well. But I want to see the explanation on the time complexity. Yeah, so it is n factorial. Okay, so it explains it here. While the theoretical time complexity is on factorial, the actual runtime is much lower in practice. So early pruning, well, yes, did talked about that. Can stop as soon as it finds the largest permutation, so avoiding further exploration of that. And sometimes you can't really like you can see the time complexity, but then you can't really get the actual correct number because like you can just kind of get the intuition of it being able to truncate like early enough. But yeah, today's one is it. It might not be too hard to think about the logic, but coding backtracking is always a very weak point for me. So, uh, well, I hope you enjoy, and I'll see you tomorrow. Bye.